I recently received a nice heavy parcel through the post from Banggood.com. So let's take a look at what's inside. Inside the package is a 125mm Sanyo K11 125 3-jaw self-centering chuck, made by the Zhejiang Sanyo Machining Company. In the package are the usual suspects, such as the chuck key, chuck jaws and fixing bolts to attach it to a backplate. First impressions are very good. The cast iron body is very nicely ground and well finished, with a nice radius on all external edges and chamfered edges on the jaw slots and the chuck key pinions. There's also a laser etched logo and details on the front face, along with a ball bearing oiler nipple. The chuck jaws are equally well finished, with a nice ground surface and a high quality appearance, again without any machining burrs, and the chuck is supplied with both inside and outside jaws to allow for work holding of a wide variety of stock sizes, making the chuck very versatile. Although a little rough sounding, the jaws moved quite freely within the chuck and it could have been used straight out of the box. But I wanted to disassemble the chuck for further inspection and cleaning prior to the first use, as quality control issues are often overlooked at the factory due to the high volume manufacturing process and time consuming quality inspections. I centre dotted the backplate and the chuck to give me a reference for reassembly and proceeded to open the chuck. So the rear cover plate was removed, which, surprisingly, was made from a lightweight cast alloy rather than the usual cast iron as expected, and this revealed the main bevel gear and the pinion bevels, which were also removed by unscrewing the 3 retaining set screws at the back. The scroll plate was gently tapped out from the chuck using a wooden dowel and a mallet and inspected for any defects. Both the main scroll bevel gear and the pinion gears looked to be cast components with a mill finish to the gears, and were acceptable but by no means precision manufactured, as there were a few minor rough edges and burrs, but these were easily taken care of by the use of a file. A paraffin wash was used to scrub all of the components of the chuck to remove any grease and grinding dust that's been left behind from the factory, and then all the parts were thoroughly inspected for cleanliness and dried using a cotton towel and compressed air prior to reassembly. I used my number punches to mark the outside of the chuck with the corresponding jaw designations and to number the pinions to make it easy to identify the jaws when fitted. I did notice that the small oiler on the front of the chuck was sitting just slightly proud of the surface, and this would be a problem when mounting stock in the chuck, as it would cause the material to sit high on one edge. So I took a short length of brass tubing and gently tapped the oiler down into the chuck body, and as you can see now, this no longer interferes with the flat surface of the chuck face. It was now time to turn a suitable backplate to mount the chuck, so a cast iron plate was bought from Myford Limited UK to suit my lathe spindle, and I opted for a plate which has 24 pre-drilled index holes around the perimeter of the plate for future indexing uses on the lathe. The backplate will require a short spigot turning on the face, known as the register, to suit the recess at the rear of the chuck, so the internal diameter and the depth of the recess was measured and compared against the specification, and then these dimensions were transferred to the backplate on the lathe. It is critical that the chuck is a precision fit to this register to ensure the concentricity of the chuck is preserved on the lathe spindle. So a rough cut was first taken and then further finishing cuts were made to bring the faceplate to final size. A groove was also turned at the PCD for marking out the holes for the fixings, and then the chuck was offered up to the plate to check it was a good fit. The bolt hole circle was marked out with the dividers on the bench, making sure that the hole placement would not interfere with the pre-drilled index point positions on the backplate. These were then centre punched and drilled out on my pillar drill to a clearance size for the M8 fixing bolts. The holes were deburred with a countersink, and the plate was cleaned up and fitted to the back of the chuck, ready to be mounted on the lathe. The chuck was then reassembled, adding machine oil to all moving parts and assembly screws, whilst checking that everything moved smoothly within the chuck. I currently use an old 4-inch Bernard 3-jaw chuck for general turning on the lathe, but I often have a need for a set of outside jaws for turning larger diameter stock. Unfortunately, I've been unable to find a set of jaws to suit this chuck. So this new Sanyo chuck with its outside jaws will hopefully solve one of my work holding problems. The specification on the package of this Sanyo chuck states a tolerance of less than or equal to 0.05mm, which is approximately 0.02 of an inch. So if it lives up to these specs, then it will be a fine chuck indeed. I also own the K13-100 6-jaw special purpose chuck from the Sanyo chuck family, and have been very pleased with the quality of this chuck, and it gets used regularly for general turning of small shafts and other delicate materials, and this chuck, with its long jaws and increased holding versatility, has got me out of jail on many jobs which my other chucks would have struggled to accommodate. You can see a review of this chuck in my video, the link to which is in the description below. This chuck runs out less than 0.02 of an inch, so I have a lot of confidence in my newest chuck from Sanyo to give me great results. So I guess it's time to test out the 3-jaw with the dial test indicator. I mounted a length of 16mm ground silver steel as my test bar in the chuck and gently tightened the scroll. I placed my DTI at approximately 1 inch from the front face of the jaws. First measurements were disappointing though, with a full indicator movement of around 4 to 5 thousandths. I reseated the bar and tightened using different chuck key pinion points, but the results were around the same, but they were consistent. I ran the DTI over the outside casing of the chuck just to see if there was any significant run out between the two, but this showed an inconsistency of just a couple of thou. So the test bar was swapped out for my precision ground cylinder square, which I know to be true, just to remove any doubt about the test bar. But again the run out was consistent with the previous tests, at around 4 to 5 thousandths total indicator movement. This was naturally slightly disappointing, and although 5 thousandths is still a very tiny dimension, I just wasn't comfortable to accept this as a tolerance margin for the chuck. So I removed the chuck off the backplate and then remeasured the backplate again on the lathe to satisfy myself that the inaccuracies were not being introduced from other factors, but the register error was less than 1/2 of a thou. The decision was made that to enable the chuck to be truly centred, it would be necessary to reduce the fit of the register to an undersized dimension, to allow for minor lateral movement of the chuck on the backplate. This, of course, goes against the purpose of the register in the first place, but I really had no other alternative other than grinding the jaws, of which I was reluctant to do. The register was reduced 10 thou off the overall diameter to allow for the correction of the error in the chuck, and the chuck was remounted back onto the backplate and back onto the lathe. The fixing bolts were gently snugged up but not tightened. This was to enable the chuck to be moved about the plate by gently tapping with a mallet, a technique known as tap-true. As you can see, the first reading was now around 15 thou out of concentricity after remounting, so the chuck needed to move 7.5 thou to remove the run out. So the high point was established, and this was rotated to the top of the chuck and a couple of taps from the mallet were applied to shift the centre position. This brought the run out down to around 7 or 8 thou, so I repeated the process several times until I got to the point where it was as close as I could get it without overshooting and having to come back the other way. I settled on a total run out between 1 and 2 thou, with tolerance of about 1 thou when reseating the test bar in the jaws, which I am more than happy with. Of course, this level of precision is probably not a necessity for the majority of turning that I do on my lathe, but it's nice to achieve a level of precision all the same. I also took some readings from the front surfaces of the chuck jaws. These also seemed well ground, with less than 1/1000th of an inch difference between the 3 jaws, which again, not absolutely perfect, but certainly acceptable. So now that the chuck is set up to the best that it can be, it's going to prove to be very versatile for my particular needs, as I can swap out the inside jaws for the external jaws at just the click of my fingers. And with the ability to hold larger round stock, will prove to be invaluable to my setup. As you can see here, the max capacity is in the region of around 4 3/4 inch diameter, and any larger the chuck jaws will start to come into contact with the bed of the lathe. All that I need to do now is build an indexing plunger pin setup to align with the indexing holes on the backplate, and I will have a full simplistic capability for turning and indexing work such as engine cylinders, covers and other similar jobs, without the constant need to change my setup. So, overall, I would give this chuck an 8 out of 10. Firstly, it is very good value for money, at around £125, which is approximately $150. And this is about 1/3 of the price that a similar Bison chuck would cost you. The general level of finish is very good compared with other engineering products which I have had from the Far East. Yes, it has a couple of shortcomings. Obviously the run out being twice that of the quoted spec was a little disconcerting, and the general lack of QA before it left the factory. But as you can see, all of these problems can be easily sorted out by spending a little time to tidy up these loose ends. I guess if these issues were put right before the chuck left the factory, then the margins would be squeezed and it would not be available at the affordable price for the hobbyist. So, if you are prepared to spend a few hours fettling and tinkering, you will get a close resemblance of what would otherwise cost 3 or 4 times as much for a high-spec chuck. Well done to Sanyo for their incredible value range of chucks, and thank you to Banggood for letting me review their product. Thanks for watching.